Hi, welcome to part B of lesson 1. And in this lesson we're going to be looking at what is programming. Now, let's start by defining what programming is. Now, programming is the process of writing logical instructions so that the computer can execute. And to execute is to work on, with the purpose of solving a problem. I want you to grab hold of 3 key words: logical, instructions, and problem. We write instructions in a logical manner so that we can solve a problem. But the only difference is that we're writing the instructions so that the computer itself can actually do the work for us. Now let's move on and look at some of the terms that you bump into when you're a programmer. But then remember, these are just the basic terms that we want to look at. So the first one is going to be the programmer. This is the person who actually writes instructions so that the computer can execute. So this is the person who sits down and then writes instructions so that the computer can actually execute. Let me explain something about programming. I'll give an example of a dog, right? A trainer is the programmer, right? A trainer will train your dog to sit, right? And then the owner is the person who comes and buys the dog, is a user, right? Now, when the owner gets the dog and tells the dog to sit, the dog is automatically going to just sit. It's because the dog has already been programmed. It has already been trained to sit. Same thing with your computer. When you buy a new laptop, phone, or tablet, it comes with programs that it has. It already has some applications and programs that it has. The programmer is the person who sits down and writes how those programs are going to work. But the user, which is you, the person who's using the application, is simply just going to take the tablet, the computer and laptop and start using the applications that are there. So we also have the program. The program is a set of instructions that performs a specific task. For example, your Microsoft Word is a program that is used to type documents and things like that. Another example is a calculator. This is a program that is used to calculate numbers, formulas, and all those things. Now, but then how the calculator works is a programmer who wrote how the calculator is going to work. And then the user is the person who's going to be using those things. And then we will move on and then look at what is known as instructions. Now, instructions are also known as code. Instructions are those lines or are orders of action which tells the computer exactly what to do. So the programmer writes instructions, but they don't know it as instructions. They know it as code. Programmers write code which tells the computer exactly what to do. And then that's how you see code will look like. But then we will get into that when we start doing the practical coding or programming. And then finally, the user. The user is the person who uses the computer programs, your applications, your WhatsApp, your Instagrams, your Microsoft Word, your calculator. You are a user if you're using it, right? And then the programmer, we've already established what the programmer does. But if you are using anything on a computer, you are the user that we're talking about. And then we need to clarify. The user sees only the nice part, the finished product and things like that. While the programmer only sees lines of code, because that is what they are tasked to do. They write the lines of code that will end up being that beautiful application that you're using for your day-to-day tasks. Remember, I said the keywords that we want to look at when we defined programming are logical, instructions, and the problem. So now we want to look at what is a problem. We have to define a problem first. Now, a problem is a gap between the existing state and the desired state. An existing state is where you are right now, and then the desired state is where you want to be, right? Not only you're thinking probably about life, but let me say if I give you 2 numbers and you want to add those 2 numbers, the where you are right now is I've got 2 numbers, but where you want to be is you want the answer. That's the problem, is the gap between the two numbers, and the answer, getting that answer. I hope that actually makes sense. So let's look a little bit further into it. Anything that does not give you the result that you need is a problem. So if you are sitting somewhere, you're calculating your accounts using your fingers or whatever, that is not going to give you the answer that you need. So that is a problem. So I'm going to give you two simple examples. The first example of a problem is going to be making a simple cup of tea. And then the next example I'm going to give you is adding two numbers. Although in real life, big problems could be queues in a bank, and the programmer is supposed to make something that is going to get rid of that problem of queues in the bank. That's why we have programs on ATM machines were designed to reduce the queues on the banks. That's why we've got internet banking and cell phone banking, is to reduce the queues on the line. That is how the programmers tried to solve that problem. But the problem was the queues in the bank. But then for now, we're going to be using the two simple examples, which is making a cup of tea or adding two numbers, so that you can have a clear vision of how you identify a problem and how you come up with the solution. So let's try and solve one of these problems. Now, every problem can be broken down into steps. No matter how big the problem is, no matter what nature of the problem, it can be broken down into steps. Let's take, for example, making a cup of tea. Making a cup of tea can be broken down into various steps, but we have to remember what a problem is. It is the gap between where you are right now and where you want to be. So right now, my existing state, the state that I'm at right now, is that I don't have a cup of tea. And the desired state is that I would love to have a cup of tea, a nice cup of hot tea. So let's break down the cup of tea into steps. For you to actually break any problem into steps, you just don't break it into steps. The question is going to be how. Remember, the third thing that we want to look at is logical thinking. Right. Now, to solve our making a cup of tea problem, you need to think logically. Now, the person is probably thinking, what is thinking logically? Now, logic is a reasonable way of doing an activity, right? A reasonable way of doing an activity. So it's like doing an activity the right way, right? It goes on to say, it is a method of reasoning that involves a series of statements. For us, in our case, are the steps. The statements are our steps or our instructions, each which must be true if the statement before is true. This can get a little bit confusing, but just to simplify it, an example is that if my previous statement is when it is cold and this statement is true by yes, then my next step should be put on a coat, which is also true, meaning that now it's logical. It's moving from one step to another because it makes sense for me to wear a coat because it is actually cold. My first statement is it cold? And then my next statement is we're cold. While we're still on logical thinking, when you break a problem into steps, when you break a problem into steps, the steps need to be in a logical manner, meaning that they have to be in a reasonable manner, they have to be in a meaningful manner, right? And you will see what I mean when we talk about need to be in a reasonable manner. Like for instance, adding two numbers, you need to capture the first number and you need to capture the second number, and then you need to add those two numbers and then get the answer. You don't start by getting the answer and then move on to, it has to be in the correct order and correct sequence, right? So logically writing these English statements or instructions, or the steps as we call them, is known as pseudocode, right? Pseudocode is just English statements or your steps that you will have written. That is your pseudocode, and pseudocode helps you to plan your code, the actual programming code that you'll be writing. Let's go back and focus on our problem, which is making a cup of tea, right? To break any problem into logical steps, you firstly create what is known as process table. This is the best way to actually separate any problem into three sections, which shows you the inputs, the processes, and the outputs, right? So you ask yourself the following questions: what are the inputs that are going to make into making a cup of tea, right? What are the inputs that you sit down and you think, what do I need to make a cup of tea? And then when you identify all of them, you list them under the inputs. You move on to looking at what are the processes involved to make a cup of tea while I'm using the inputs that I have listed, right? So whatever process you're going to talk about, you're going to be using those inputs that you have come up with. And then what is the output that I am intending to get out? What is the solution? What are the results? So let's take a look at what it looks like. For my cup of tea, my inputs are going to be water, sugar, milk, the tea bag, a kettle, a cup, and a spoon, right? Those are the things that I haven't mentioned the fire, I haven't mentioned electricity, the stove, because these are external things. I am focusing on my cup of tea, things that are directly connected to my cup of tea, right? So I've listed my inputs. And then the processes, this kind of reminds you back to the first lesson that we had, the input, process, and then the output, right? The processing that's going to happen is that I'm going to boil water in a kettle. I've already used one of my inputs. I'm going to pour the hot water into the cup. There goes another input, which is the cup. And I'm going to put the tea bag, the milk, and the sugar into the cup with the boiling water. Can you notice that everything is being used from my input? And then finally, I'm going to use the spoon to mix. That is the last process that I'm going to have. And then out of all those processes, what am I going to get? I'm going to get a hot cup of tea. Now that we've created a process table, it's now time to actually look at the logical steps, the pseudocode. Remember I talked about pseudocode, which is writing your instructions in a logical manner, right? Yes. Now let's write the pseudocode, which is the logical steps which makes a cup of tea. Let's see if it is going to be that complicated. Well, no. Your first step, you just write input. And what are you inputting? You name all the things that you're going to input into your program, which is your water, your sugar, your milk, your tea bag, and your cup. And finally your spoon, right? And then when you do that, then you start writing the steps in a logical manner. What will you start with doing after you have all the ingredients? Well, I'm going to start with boiling the water using the kettle. And then when I finish boiling the water using the kettle, I'm going to pour the boiled water into a cup, right? Can you see how the first step can lead to the next step and then go to the fourth step, which is to put the tea bag, the milk, and the sugar into the cup with the boiled water, and then finally I use a spoon to mix. And what do I get out of all those processes? My final step is going to be my cup of tea. We're done. This is how you write the pseudocode, right? Okay, now let's try another problem, right? We had mentioned two problems, which is one was a cup of tea and then this one adding numbers. So for adding two numbers, what we're going to do is that our problem is adding two numbers, and then adding two numbers, well, in mathematically it's looking for the sum, right? And then so let's break down the sum problem into steps, right? Remember we said the first thing that you're going to do is that you're going to break it into a process table. You have to identify what are the inputs, what is the process, and then what is the output, right? So if you've done that, you ask yourself the following questions. What are the inputs that go into getting the sum of two numbers? Well, obviously, my inputs are going to be my first number and my second number, right? And then what are the processes that are going to be involved? It's just adding two numbers. We don't have too much that we're going to do on these things. We're just going to add the two numbers. That is the process, right? And what are we expecting to get out? Well, I'm expecting to get the sum, which is the total of those two numbers, right? So my table will look something like this. Under my inputs, there's the first number, then the second number. Under my processes, I'm going to have I'm going to add the first number and the second number together. And then my output is going to be the sum. Now that I've done that, I go on and I move on to writing my pseudocode, right? Now, well, let's go on. Now let's write the pseudocode, the logical steps that calculate the sum of two numbers. The first step is going to be writing input the first number and then input second number, right? And then I move on to what I've got the two numbers. The only thing that's left for me to do is to add those two numbers. So that's the process. I'm going to add the first number and the second number, right? And then the last thing that I'm going to do is that I'm going to output, because now I want to know what is the answer of the two numbers that I've added. And then I'll get the output in that manner. Then we get our sum. And then we're done. So what you've learned in this lesson is that programming is writing logical instructions. So in the process of solving a problem. And then what we've done is that we've actually identified two simple problems, and then we've broken them into steps using the process table, and then we came up with the pseudocode. And this pseudocode, those logical steps are the ones that assist you in writing your programs, right? Well, stay tuned for the next lesson.